Well, get this. Scientists could bring Neanderthals back to life within the next 20 years. Not as fossils, not as simulations, but as actual living beings. And no, this isn't a sci-fi movie pitch, but a real debate happening right now in genetics labs and ethics panels around the world. The DNA has already been decoded, and the only thing standing between us and a living Neanderthal is whether we should do it, not whether we can. So let's get some things clear. Neanderthals weren't cavemen dragging clubs around as cartoons taught us. They were just like humans, our close cousins, who lived across Europe and Asia for hundreds of thousands of years. They cared for injured members of their society, made tools, wore clothing, and survived scary Ice Age conditions that would wreck most modern humans. Then, around 35,000 years ago, they vanished. No one fully agrees on why. Changes in temperatures, competition with Homo sapiens, health issues, or interbreeding. All of it probably played a role. The reason this resurrection talk even exists is that scientists finished sequencing the entire Neanderthal genome back in 2010. It's like an instruction manual written in DNA, telling a body how to grow, function, and survive. Now, once you have that manual, the question shifts from what were Neanderthals like to could we rebuild one? This is where CRISPR enters the story. It's a gene editing tool that works like molecular scissors. It lets scientists cut DNA at precise spots and replace sections with different genetic code. They already use it to study health conditions, edit embryos in animals, and even modify human stem cells in labs. Now, in theory, scientists could take human stem cells and slowly replace modern human DNA with Neanderthal DNA, piece by piece. One famous geneticist from Harvard says it could happen within a couple of decades. He doesn't mean that copying a Neanderthal straight from a fossil, because ancient DNA is too damaged for that. Instead, his idea is to take human DNA and slowly change it piece by piece until it matches Neanderthal DNA. So it wouldn't be a copy from the past, but a modern human body rebuilt using Neanderthal instructions. Whoa! Scientists are willing to go through all that because they want answers to questions like why Neanderthals disappeared and we survived. How did their brains work compared to ours? Did they think differently, feel differently, or process language in unique ways? A living Neanderthal could answer questions that bones and fossils never can. Some researchers even think this could help modern medicine. Since Neanderthal genes influence immunity, metabolism, and inflammation, studying a full Neanderthal biology could reveal why certain conditions hit humans the way they do today. So, in a strange way, reviving them could help us. But all this excitement hits a wall made of ethics. A Neanderthal wouldn't just be a lab mouse, it would be a person. That single fact flips the entire project upside down. You can't treat a person like an experiment, even if science really wants answers. Being the only Neanderthal on Earth would be tough, to say the least. They'd have to live with no culture, no community, no one who would want to truly share their biology. They'd grow up surrounded by modern humans who would study them nonstop and forever label them as an experiment. So, critics of the idea are sure that kind of isolation could cause serious psychological damage. There's also the issue of consent, which the experiment would completely break. No Neanderthal can agree to being born into a modern world, raised by humans, studied for life, and used as proof of a theory. Consent is crucial in medical ethics, and you can't even test meds without it. Cloning a human ancestor would break that rule. Now, if we forget about ethics, there are also serious biological risks. No one knows how a reconstructed Neanderthal genome would behave in a modern human womb. Pregnancy alone could be dangerous. Development might not follow expectations. Immune reactions could go wrong. Even small genetic mismatches can cause massive problems when you're building a whole human from scratch, you know. And even if everything worked out, the results might disappoint. One individual couldn't recreate Neanderthal society, and behavior comes from culture as much as DNA. Without a full population, the answers we get could be shallow, misleading, or incomplete. The debate on whether we should or should not bring back Neanderthals is so intense because the possibility of doing so is very real. Genetic engineering keeps accelerating, and the tools keep getting cheaper, faster, and more precise. Right now, no lab has approval to try this. No Neanderthal embryo exists. But scientists, ethicists, and state officials already argue about rules, limits, and red lines, which is another proof of how close it feels. It also brings up the big question of whether scientific curiosity has limits and who gets to decide them. Right now, there's no law that bans resurrecting extinct humans. Once one country allows it, others could follow, faster than the rules can keep up. And then, there are scientists who counter all this with a different argument. What if not doing it is also unethical? They point out that we already revive extinct animals, manipulate genomes, and alter life at the deepest level. Understanding Neanderthals could help modern humans survive future climate shifts or mass health disorders. If Neanderthals thrived in extreme conditions, their biology could hold survival clues we desperately need. From that perspective, if we refuse to explore this knowledge, it could cost the world many lives someday. If all this doesn't touch your heart at all because you have nothing to do with Neanderthals, here's a surprise for you. When you look in the mirror, you're probably staring at a tiny piece of one of them. It could literally be in your DNA. According to a study from a couple of years ago, Neanderthals didn't just vanish into thin air, but blended into us. Modern humans, whose ancestors migrated out of Africa, carry about 1 to 4% of Neanderthal DNA. Scientists only have a handful of high-quality Neanderthal genomes to study, just 3 really solid ones. They come from bones found in a cave in Croatia that are about 50,000 to 65,000 years old, plus 2 others from Eurasia dating to around 80,000 and 50,000 years ago. It's not a lot to work with, which means every new discovery matters a lot. Every person has 2 versions of each gene, one from mom and one from dad. When 2 very different groups mix, their offspring end up with more genetic variety. The scientists compared DNA from those 3 Neanderthals with genetic data from about 2,000 modern humans. What they found was shocking. Neanderthals themselves may have carried up to 3.7% modern human DNA. So Neanderthals weren't just mixing into us, we were mixing into them too. Roughly 1 out of every 30 Neanderthal parents may have been a modern human. And this didn't happen just once. The DNA shows at least 2 big periods of mixing. One happened around 200 to 250,000 years ago, and another around 100 to 120,000 years ago. There may have been more, but DNA is like a blurry photo. The older the event, the harder it is to see clearly. According to another recent study, most Neanderthal DNA in modern humans came from one long, intense mixing period about 47,000 years ago that lasted nearly 7,000 years. That's generations growing up together. This lines up with real bones, too. Scientists found skulls about 100,000 years old in Middle Eastern caves that look mostly like modern humans, but with thick brows and other Neanderthal-style features. Sadly, it looks like Neanderthals had a much smaller population than scientists thought. This makes it harder for them to stay genetically separate. As waves of modern humans kept moving out of Africa and mixing with them, Neanderthals didn't disappear, but dissolved into the larger human population. So, Neanderthals didn't lose the game of evolution. They're part of us. It's something worth keeping in mind when you think about the ethical side of bringing back one of them.
You're way more Neanderthal than you think, at least when it comes to your DNA. These ancient hominids were shorter and stockier than humans today. They made stone tools, used fire, wore clothing, and had some rituals of their own. The official theory says that they went extinct 40,000 years ago, But a new study says Neanderthals probably never really disappeared completely, but could have mixed with modern humans. It looks like every modern human has about 3% of the Neanderthal genome in their DNA. If it's accurate, it means Neanderthals were more connected with our ancestors than we previously thought, and shared a long history of living together. Neanderthals were very close relatives of modern humans, but our families separated about 500,000 years ago. More than 10 years ago, scientists discovered that Neanderthals had families with the early humans who traveled out of Africa. Because of this, people living outside of Africa today have about 1 to 2% of Neanderthal DNA in their genes. We now have only 3 really good examples of complete genetic code from these ancient hominids. The first one comes from bones found in a cave in Croatia that are 50,000 to 65,000 years old. 2 more examples, which are about 80,000 and 50,000 years old, were found in caves in Eurasia. Scientists still aren't sure as much about how modern human DNA got into the Neanderthal genetic alphabet because they don't have enough material to study. But they did compare the existing DNA of 3 Neanderthals with the DNA of 2,000 modern humans. They found that the Neanderthal DNA might be made up to 3.7% of modern human genetic code. It means that in the ancient Neanderthal population, about 1 in 30 parents were modern humans. The scientists found that modern human DNA got mixed into the Neanderthal genetic alphabet during at least 2 periods when humans and Neanderthals were interbreeding. This happened once about 200,000 to 250,000 years ago, and again about 100,000 to 120,000 years ago. There might have been other times they mixed, but we can't see those in the DNA we have now. Another recent study, which hasn't been fully checked by other scientists yet, says that most of the Neanderthal DNA in modern humans came from one big period of mixing, about 47,000 years ago, that lasted for almost 7,000 years. Scientists found skulls that are about 100,000 years old in 2 caves in the Middle East. These skulls look like they belonged to early modern humans, but have some features like bigger eyebrows that might show they had Neanderthal DNA. This could be because of gene flow from Neanderthals, and it fits in the mixing time frame. The study also looked at the genetic differences in the 3 Neanderthal genomes and found out that Neanderthals had an even smaller population than scientists thought before. It could be another proof that Neanderthals didn't just go extinct, but became part of the modern human gene pool. Many groups of modern humans left Africa and mixed with Neanderthals so much that Neanderthals couldn't stay separate. In the future, scientists want to study how modern human DNA affected Neanderthals. This could help us understand if this mixing had good or bad effects on Neanderthals. Neanderthals aren't our only relatives from the past. There used to be at least 9 species of humans on our planet. One of them, Homo habilis, earned the nickname handyman because stone tools were found with its remains. It lived in eastern and southern Africa. This early human had a slightly larger brain than its older relatives and an ape-like face. Homo habilis was about 4 feet tall and ate a variety of foods. For a long time, scientists thought Homo habilis was the oldest member of our human family. But new dating methods have shown that Homo erectus, another ancient human, might be older and not related to Homo habilis. Homo naledi is a more mysterious member of our human family, discovered in a South African cave in 2013. It's the only region of the world where their remains were found. They walked on 2 feet, but were also good at climbing trees. They were small, about 4 feet 9 inches tall, weighed around 88 pounds, and had small brains. We don't know much about how they lived since we haven't found stone tools or other cultural evidence. But some scientists think they might have buried their deceased and made cave art. In 2010, scientists found some fossils in a cave in Siberia, but they weren't sure what species they belonged to. These fossils are from a group called the Denisovans, who lived between 194,000 and 51,000 years ago. We don't know much about them because we only have a few fossils. But DNA analysis has shown that Denisovans were closely related to Neanderthals and modern humans. They even had families with early humans, especially in Southeast Asia. There aren't enough fossils to give Denisovans their own species name, but their genes are found in modern humans, which means they might be part of our own species. As scientists study more about Denisovans and fossils in Southeast Asia, we might understand better how different species fit into the Homo family tree. In 2003, they found fossils of a very small human-like species in a cave on the island of Flores in Indonesia. These tiny people lived between 100,000 and 50,000 years ago. They were only about 3 feet 6 inches tall. Scientists think they might have come from another species, Homo erectus, and became smaller over time because they lived on an island with limited food. Because of their small size, they're often nicknamed hobbits. Around 40,000 years ago, Homo sapiens, yep, that's us, were the last humans left out of many different kinds of human-like species that walked on 2 legs. So, the logical question is, what happened to the others? And what did we have to do with their disappearance? Some scientists think we survived because our offspring lived longer, or because we were better at handling changes in the weather. Others think we might have competed with other human species, or maybe mixed with them and shared genes. About 300,000 years ago, the first Homo sapiens lived in Africa. They didn't look exactly like us, but they were more similar to us than other early humans. They had tall, round skulls with almost straight foreheads. Unlike Neanderthals, they didn't have thick brows or jutting jaws like Homo naledi. They also had chins, which no other early humans had, though we still don't know why. Homo sapiens lived in bigger groups and had more genetic diversity compared to other early humans. This helped us in many ways, not just in staying healthy. Having big social networks across different places was like having a safety net. If we ran out of food or water, we could go to other groups we were connected to, and they would help us because we weren't strangers, we were family. These big networks also helped these early humans share new ideas and inventions. A big simulation showed that later species of humans could live in many different environments because of these wide networks and the ability to adapt. We know that Neanderthals were really smart, but Homo sapiens might have been just a little bit smarter. Small inventions like weaving and sewing needles could have given Homo sapiens an edge. Scientists have found evidence of weaving from 35,000 years ago and sewing needles from 30,000 years ago. Weaving lets you make things like baskets and nets to catch food. Sewing needles help you make better clothes and tents, which keep you and your youngsters warm and safe, which is very important for survival.
Imagine standing in the middle of Europe 40,000 years ago. The landscape is rough, cold, and unforgiving. Fast food is scarce, and there's no internet. Suddenly, from out of the woods steps a figure, stocky, strong, and with a face that is quite unusual. This human looks similar to us, but something about them is different. Their brow is heavy, their nose is broad, and their body seems to be built to fight nature itself. Well, congrats! You've just met a Neanderthal. You might have thought that Neanderthals were basically ancient humans, but that's not really true. We come from the same genus called Homo, but we, all modern humans, belong to one same species called Homo sapiens. However, there used to be lots of human species before, and Homo neanderthalensis was just one of them. And they actually were kind of cooler than us. So what in the world has happened to them? Neanderthals lived for a long time, for about 360,000 years, across Europe and parts of Asia. 40,000 years ago, the place we now call southern Italy was sitting on top of a huge disaster, a massive supervolcano called Campi Flegrei. This big boy is huge, about 9 miles wide. That's about 10 to 20 minutes in a car to get across it all. But there were no cars then, remember? At the time, it was quiet for a while, but one day, suddenly, it blew in what became one of the biggest volcanic eruptions Europe had seen in 200,000 years. The catastrophe was so crazy that ash, gases, and debris altered the climate across the entire continent. What comes next is usually called a volcanic winter. Average temperatures drop, the sky gets darker, and life becomes even harsher than it already is. The eruption, known as the Campanian Ingombrite, caused Europe to cool by as much as 7 degrees Fahrenheit. Doesn't sound like much? Well, the drop of even 1 degree would cause winters to become harsher, causing horrible snowfall, rains, and floods. Crops would struggle to grow, leading to food shortages. The weather would go wild, too, with storms and droughts. Hey, kind of like now. Except multiply this by 7. Events like these caused some huge chaos in modern times. You can imagine what it did to the Neanderthals. But in reality, a simple volcanic eruption shouldn't destroy an entire species, right? Well, yes. The truth is, the Neanderthals were already hanging by a thread back then, and all because of us. They've been in a tough spot for a while. They lived in places that are now parts of Europe, Western Asia, and the Middle East. Modern humans, us Homo sapiens, entered Europe and were giving them some serious competition for food and shelter. Homo sapiens were sneaky dudes, better at finding food, easily adapting to different environments, and using more advanced tools. We were pushing Neanderthals out, trying to get the same resources. We literally made their extinction a slow and very unpleasant process. So, while the volcano definitely made things worse, it wasn't their only problem, and they didn't completely disappear after the eruption. Some of them hung on in isolated places, like Gibraltar, for another 12,000 years. That's because it's likely most of the severe cooling actually happened farther east, away from where the Neanderthals were trying to survive, and it didn't hit their homes as hard as we thought. In fact, the eruption may have even helped them, at least for a while. Some scientists say that the volcanic fallout might have slowed down modern humans' expansion into Neanderthal territory and gave the poor fellas a little more time to survive. So, the Campiflagre eruption was a nasty event, but it only delayed the inevitable. Campiflagre is a wild card. It's also known as the Fields of Fire. The air itself there is thick with legend. The Greeks and Romans believed this volcano was the gateway to the underworld. Even an ancient Roman poet, Virgil, mentioned this in his famous story, the Aeneid. The hero Aeneas must descend into the underworld, and this place is exactly where he starts. Back in the day, this landscape was full of Roman villas, spas, and fish ponds. The elite had the time of their lives there. What they didn't know, though, was that they were standing on treacherous ground that could go crazy at any moment. The Campiflagre is not your typical volcano. You'd imagine a single towering peak, but the landscape looks deceivingly calm, with small features popping up here and there. But if you flew above it, the sight would be insane. A gigantic circular basin, peppered with volcanic cones and craters, like scars from the Earth's violent past. The danger here lies in its subtlety. The ground beneath your feet is constantly shifting, even when you don't notice it. Every so often, the land rises, only to sink again, sometimes by several feet, as magma or gas moves beneath the surface. It's incredibly creepy. The risk is almost invisible. The Campiflagre is a massive depression formed by 2 colossal volcanic eruptions. One of them was the one that cooked Neanderthals, and another happened 15,000 years ago. The most famous eruption, though, happened in the 16th century, and it was horrifying. The year was 1538. For years, the people of Paswali had noticed something unsettling. Land that once sat below the waves was slowly rising. What was once the sea had become new ground. Rumblings from deep within the earth were terrifying, but had become a normal part of life. Earthquakes started in the early 1530s, small at first, but in just 8 years, they became the norm. Until one day, on September 28th, horrifying tremors shook the ground. By the next evening, as the sun dipped below the horizon, a massive crack ripped open the earth near the ancient Roman town of Tripurgole. From this gash spewed fire, smoke, and a rain of volcanic ash miles away. It was thick and muddy, likely mixed with underground water. The ground trembled as hot pumice rock was thrown high into the air. And then a new mountain began to rise from the land. This was the birth of what we now call Monte Nuovo. Eventually, things seemed to calm down, as if the earth was catching its breath. For days, things seemed quiet. Locals relaxed a bit. They began to approach the new mysterious volcano, a crater with something that resembled boiling within it. People visited it like a new attraction. But then, just days later, the disaster struck again. At night, without warning, a new mountain went wild. A blast from the southern flank hurled scoria, chunks of jagged volcanic rock, into the air. This one was fatal for 24 people. The debris found afterwards was huge and coarse. For centuries after, the only signs of life from the Monte Nuovo were small fumaroles, jets of gas seeping from the earth. But then, even those faded away. Now it's just a lush green cone, a pretty sleeping giant. But the ground near Naples, Italy, is still alive. The Campi Flegrei sits quietly for now, but it might not be for long. It's showing signs it might be waking up again. This supervolcano looks like a hellish landscape, with its boiling mud pits, geysers, and steam vents. Romans and medieval Christians once believed it was a gateway to the underworld, and who can blame them? What's spooky is that recently scientists detected unusual activity under the surface. In 2012, Italian authorities raised the alert level on the volcano from green to yellow, meaning that it needs close monitoring. There are certain changes that usually happen before an eruption. The magma below starts releasing gases, which could weaken the rock above, eventually triggering a disaster. Unfortunately, no one can predict exactly when or if it will erupt. But if it does, the consequences could range from a minor inconvenience for locals to a global catastrophe. Its last tiny eruption happened in the 16th century, and it wasn't too bad. But if history repeats itself, like it was with Neanderthals, we're all cooked. An eruption like that could lead to global cooling, crop failures, and widespread famine. Right now, a group of scientists is trying to get a clearer picture of what's happening beneath the surface. The Campi Flegrei Deep Drilling Project is working to drill a 10,000-foot borehole, hoping to check out the magma chamber up close. But at least for now, the supervolcano remains quiet, and let's hope it stays that way.
Hey, check this out. Does this pebble look like a face to you? Especially with that red dot in the middle. If yes, you might be staring at the world's first emoji. It was uncovered in Spain and it's 43,000 years old. And that red spot was made by a Neanderthal with a finger. That means this isn't just a dot. It's the oldest fingerprint ever found. But was this really a nose on a grumpy face? And why is that important? Because it hints at something big. A mind seeing shapes, then choosing to add meaning. The palm-sized rock was discovered in a Paleolithic rock shelter tucked away under some light-colored chalky cliffs. It was pretty much a natural overhang where Neanderthals used to hang out. They called it home tens of thousands of years ago. As for the pebble, to me, the dot seems like a random ketchup stain from ages ago. But real archaeologists know better. The neat placement instantly caught their attention. After running tests, they determined that the stain wasn't natural. It seems intentional, not random. Their guess? Someone thousands of years ago may have dipped a fingertip into a mix of ochre pigment and water, then pressed it onto the stone, leaving a tiny prehistoric stamp. To put that theory to the test, they called forensic experts from Spain's national police. At first, the specialists were pretty doubtful. After all, this was the ultimate definition of a cold case. But with multispectral imaging, which lets scientists study surfaces under different wavelengths of light, something amazing popped up: clear fingerprint ridges. The print's rounded form showed it came from the tip of a finger. Comparing it with fingerprint databases, the evidence pointed to one likely candidate: an adult male, not a woman or a child. Finding any fingerprint this old is insanely rare. pigments usually fade, rocks erode, and time wipes away delicate details like ridges. When it comes to fingerprints, the unique patterns actually form before you're even born. During pregnancy, they never change. You might wonder, could a clever criminal damage their skin to erase their fingerprints and fool the cops? Turns out that's basically impossible. Fingerprints aren't just on the surface. They form deep in the skin, in a layer called the dermis. Even if you burn, cut, or scar the outer layer, the patterns underneath usually stay the same and even heal back. Scars might distort the print a little, but that won't help. Ironically, those scars often become a new kind of fingerprint, unique to the person. With today's forensic tools, even a partial print is enough, not to mention the DNA. Yes, fingerprints are just patterns, but they usually come with sweat, skin cells, or oils that may contain DNA. Here's another cool fact. Koalas also have unique fingerprints just like we do. Under a microscope, even experts sometimes struggle to tell them apart from human prints. Scientists think these ridges help koalas grip branches and pick leaves with precision. The bottom line, fingerprints are basically nature's unhackable signature. It's something humans, Neanderthals, and apparently even koalas have been leaving behind for tens of thousands of years. If it's been a while since your biology classes, here are some clarifications. Neanderthals weren't our direct ancestors, they're more like our long-lost cousins. Colloquially, we call them humans too. But for scientists, Neanderthals and modern humans were different species within the same genus. Kinda like how lions and tigers are both big cats, but they're not the same species. Homo sapiens and Homo neanderthalensis split from a common ancestor hundreds of thousands of years ago. Neanderthals dominated Ice Age Europe. When Homo sapiens arrived around 45,000 years ago, the two met, mixed, and today, most people outside Africa carry about 1 to 2% Neanderthal DNA. Eventually, the balance shifted. Within just a few thousand years, Neanderthals disappeared, while modern humans kept spreading. Scientists think it was a mix of different factors. Shifting climates made food scarce, new neighbors brought competition, and their small, scattered populations just made survival even tougher. Now, here's why this little fingerprint is such a big deal. For decades, scientists thought Neanderthals were just built for survival. Strong, but simple. Homo sapiens were supposed to be the creative ones. For a long time, scientists thought they were special because they could think in symbols. Tens of thousands of years ago, our ancestors carved patterns into stones, painted animals on cave walls, and wore beads and pigments as decoration. The earliest proof of symbolic art comes from Blombos Cave in South Africa, where humans etched deliberate designs on pieces of red ochre over 70,000 years ago. Those symbols had no survival purpose. Researchers believe they were expressions of ideas, identity, and meaning. That ability to imagine and represent things we couldn't see was thought to be uniquely human. But this one tiny red dot on a stone challenges that idea. See, the stone already looked like a face, and someone all the way back deliberately pressed a red nose right where it should be. That's symbolic thinking. That could mean that Neanderthals weren't just making tools and hunting mammoths. Perhaps they were able to imagine things. And this isn't just the only clue. This fingerprint is part of a growing pattern that shows Neanderthals were way more like us than we ever believed. For example, in Cova Negra, Spain, archaeologists uncovered the skeleton of a Neanderthal child who had a serious ear condition that made life incredibly hard. However, the little one lived to be around 6 years old. Now, remember, this was the Ice Age. Just managing on your own was challenging. Survival was tough. Food was scarce and danger was everywhere. Yet, someone made sure that the child was looked after, fed, and kept safe. Scientists believe that this shows a trait of compassion, something we once believed only our species was capable of. In Iraq, scientists found a Neanderthal skeleton sprinkled with flower pollen. Sounds random. Maybe not. Some believe it was part of a funeral ritual, like the world's first floral tribute. If that's true, Neanderthals weren't just surviving, they were remembering and honoring life. Neanderthals were apparently quite resourceful. Around 176,000 years ago, they were stacking stalagmites into neat circles in Bruniquel Cave in France. Was this some kind of ritual or just curiosity? Maybe this means that they had the idea of planning and changing their surroundings. Then, around 130,000 years ago, they took eagle talons and turned them into jewelry in Croatia. Yep, early bling. This suggests they were into looking good and possibly showing off a bit socially. There were no sewing machines back then, but Neanderthals had stone scrapers and even bone needles. With those, they crafted animal skin outfits that were perfect for the freezing Ice Age climate. When you step back and consider all of these, that tiny red fingerprint isn't just a mark on stone. If it was meant to represent a nose, it's part of a much bigger story. Neanderthals cared for one another, crafted tools and clothing, created jewelry, painted on cave walls, and built mysterious structures deep in caves. Basically, they were thinking a lot more like us than we used to imagine. And here's the fun part. What if that little red dot wasn't meant to be a nose at all? Maybe it was a joke, a charm, or just a doodle. Heck, it could have been the first face meme scratched onto rock. Whatever it was, unless it really was an accident, it shows imagination. So the next time you send an emoji, remember that Neanderthals had the same idea. Personally, I like that it's a grumpy one, but at the very least, we now have the oldest fingerprint ever discovered. That alone is extraordinary. But add the fact that the print was placed right on a stone that already resembled a face, and suddenly, the questions multiply. Let's hope the researchers discover more about it so we can know for sure. What we do know is that 43,000 years ago, a Neanderthal pressed a finger onto stone and left us with one of the most personal signatures in prehistory.
Admit it, whenever you think about Neanderthals, you picture these large, human-like creatures wandering around, bumping their heads, afraid of fire, and making weird noises. That's really far from the truth. There's actually more Neanderthal DNA in your genome than you know. It's estimated that up to 4% of the DNA of some modern humans can be traced back to Neanderthals. If you have no idea who these people were, let me get you up to speed. The Neanderthal was a species of early humans that lived in Europe and Western Asia as early as 200,000 years ago. As for their appearance, they looked sort of like us, but they were physically stronger. Their skeleton was also more durable and able to cope with the harsh environment. I mean, 200,000 years ago, people didn't live in houses or apartment complexes. So, their bodies needed to be able to survive in the wild. What's even more surprising is that their brain was larger than ours. But did that make them smarter? To answer that question, let's look at how these people lived back then. Neanderthals were hunter-gatherers, meaning they had to hunt and search for food. Back in their prime years, farming wasn't la mode yet. They were skilled at making tools and objects to protect themselves with, like spears and stone knives. They used these things to hunt animals, yes, but also to make clothing. And speaking of garments, a new study showed that Neanderthals might have been more fashionable than we'd previously suspected. These recent findings show that they may have been skilled in using plants to create yarn. This is based on the discovery of pieces of fabric from over 50,000 years ago in parts of Europe, where Neanderthals used to live. This is really important because it's rare for archaeologists to find perishable artifacts, such as plant products. Most of the things we find these days from previous eras are pottery and pieces of rocks and bones because they can better resist the test of time. Researchers used a special microscope to examine a cord fragment made of twisted fibers, which may have been used for a tool or net. Since it looks like they were able to twist plant fibers into making a cord, Neanderthals had probably been much smarter than we thought. It shows that they had great observational skills and were great at picking out which sort of plant was better to use. They also used fires to keep warm and cook food. It looks like Neanderthals were able to make use of flames that popped out spontaneously but were not able to create them consistently. Scientists have looked at some Neanderthal sites and found large amounts of ash. That means they had to constantly maintain a fire because they were unable to start it again if it went out. Other specialists believe Neanderthals did use fire, but they did not necessarily need it due to their physical abilities, which allowed them to handle cold temperatures better than modern humans. So, what did Neanderthals eat? Scientists have been able to get a glimpse into their menu, but that's only because these ancient creatures had this nasty habit. They didn't brush their teeth. If you don't brush your teeth regularly, a film called dental plaque will form on the surface of your pearly whites. Over time, this plaque will harden and turn into tartar or dental calculus, which is a combination of minerals, microbes, and leftover pieces of food. Scientists can use bits of the material trapped in dental calculus on fossils to study what our distant cousins ate and what their lifestyles were like. They can also examine ancient DNA to determine the species of microbes present in the mouth of a Neanderthal. Turns out that those living in Belgium ate mostly meat, including woolly rhinoceros and wild sheep, according to the DNA found in their teeth. On the other hand, the Neanderthals found in the El Cedron cave in Spain had a more plant-based diet, including mushrooms, pine nuts, moss, and tree bark. Other Neanderthals from different locations also showed consistent evidence of eating plants. One of the Spanish Neanderthals even had dental problems, and the researchers found evidence of medicinal plants in his teeth. He may have been trying to treat his pain. Another study performed at the University of York found that Neanderthals had some sort of prehistoric healthcare system. It worked regardless of how bad the injury or illness was. The research suggests that this care was provided out of real concern rather than self-interest. This challenges the stereotypical image of Neanderthals as brutes and selfish creatures compared to modern humans. The study found that many Neanderthals had severe injuries requiring ongoing care, such as massage, fever management, and hygiene. One individual who was around 25 to 40 years old at the time of his passing had a degenerative disease that likely severely limited his ability to contribute to the group. Despite this, he was carefully buried, which shows that he remained an important part of the group, despite not being able to contribute much to the daily workload. In case you're wondering, Neanderthals aren't technically our direct ancestors. They're sort of a distant relative, if you'd like, because some of them lived at the same time as modern humans. We coexisted for thousands of years, with Neanderthals living in Europe and Western Asia, and modern humans spreading out of Africa around 50,000 years ago. There is evidence that the two species interacted and even interbred. That's why some humans today have Neanderthal DNA in their genetic makeup. However, the precise nature of their relationship is still debated among scientists. Despite their physical advantages, Neanderthals eventually went extinct. Some people think Neanderthals as a species were not successful because they disappeared a long time ago, but they actually did very well. They lived in difficult conditions for a very long time, much longer than modern humans have been around. Modern humans have only been around for about 100,000 years or so, and only started living in cold areas about 40,000 years ago. There are many factors that may have led to the extinction of Neanderthals. It is believed that changes in their natural climate and competition with modern humans were two of the main reasons. Neanderthals specialized in hunting certain animals, but when those animals went extinct, they may have struggled to find food. Additionally, modern humans had advantages, such as trade networks and better technology, including sewing needles or bows and arrows, which may have given them a competitive edge. Although there is no evidence of direct conflict between the two species, it is known that they interacted. Some people even believe that Neanderthals did not fully go extinct, since their traces of their DNA can still be found in some people. So, what if the Neanderthals hadn't gone extinct? Charles Darwin pointed out that many of the unique traits of humans, like emotions, intelligence, language, and social behavior, can also be seen in some form in other animals. Our closest relatives, such as Homo erectus and Neanderthals, were also quite similar to us. However, Homo sapiens are the only surviving members of the hominin group, which includes around 20 known and potentially many more unknown species of humans and human-like apes. Even if the Neanderthals had survived, they would have probably integrated into society and evolved at the same time as modern humans did. One theory suggests that since they were outnumbered at one point by Homo sapiens, their traits would have eventually merged with ours. Those less advantageous, like their inability to produce fire, would have disappeared over generations. Other theories suggest that maybe they wouldn't have wanted anything to do with us. Looking at our differences rather than our similarities, maybe they would have developed their own communities, choosing to live separately from the modern world. Either way, it's hard to predict how a species that disappeared so many years ago would behave today. But what we do know is that you need to think twice next time you want to call someone acting weird a Neanderthal. Your DNA might make you the Neanderthal in the room.
Remember the Neanderthals? Our superstar humanoid cousins of the Pleistocene era in all their wide-nosed and slope-foreheaded glory? They roamed through Europe and Asia for over 350,000 years before they vanished. This was around the same time our ancestors, the Homo sapiens, decided to take a vacation from Africa and explore the world. We may never know what truly happened to the Neanderthals and why they didn't make it to the present times, but thanks to some hefty archaeological digging and impressive fossil finds, we now know a bit more about them. One theory for their disappearance is that the climate wasn't suitable for them anymore. Supporters of this idea think Mother Nature turned on the Neanderthals and sent them packing. Unfortunately, if we look at Neanderthal archaeological sites in Italy, for example, there are no signs of weather catastrophes that could have wiped out this entire species. Others believe there was a bit of resource competition between Neanderthals and humans. That's why specialists also dug around several other archaeological sites where Neanderthals and sapiens might have rubbed elbows for about 3,000 years. In this case, it does seem that the Neanderthals were a bit behind with their tools. Their technology was like flip phones in the age of VR. But who knows if these two species ever crossed paths in that particular region? The evidence is still fuzzy. How they went extinct isn't the only information we're curious about when it comes to Neanderthals. Other scientists, for instance, are trying to decode some of the Neanderthal molecular barcodes to identify their specific traits, some of which you might share, believe it or not. Sure, Neanderthals as a whole species did, in fact, go extinct. But that's not to say remnants of their DNA can't be found in humans. Now, you know how things go when folks live near each other. Some genetic mixing was bound to happen. The evidence? A dash of Neanderthal DNA which was found in modern folks. Now, this is where the plot thickens. Scientists thought that since Neanderthals never lived in Africa, their DNA wouldn't be found in modern African populations. Well, it turns out that African people have about 0.5% Neanderthal DNA too. This doesn't mean our Neanderthal relatives simply teleported through African territories without leaving any trace behind. What this discovery actually implies is that early humans might have visited Europe, mixed their genetic material with that of Neanderthals, after which they returned to Africa. That's a lot of migration. How did we stumble upon that Neanderthal DNA these days, you might wonder? Well, scientists gathered thousands of people from all around the world. Participants came from places like East Asia, Europe, South Asia, America, and Africa. Percentages may vary, sure, but around 20% of the good old Neanderthal DNA is still found in US modern folks. Sure, the average Joe only carries about 2% of that caveman swagger. If you're from certain places or families that have a smidge more Neanderthal in their gene soup, you're looking at 3% tops. Is there anything in particular that we share with our long-gone humanoid cousins? As it turns out, our Neanderthal ancestors gifted us more than just their company for some thousands of years. They also passed down the incredible legacy of their noses. Well, you see, the Neanderthals were outfitted with some seriously high-rising sniffers. These weren't just cosmetic, they were also quite the asset in chilly climates. The icicle-dripping, teeth-chattering kind of cold where your breath could freeze before it leaves your lips. During those days, the Neanderthal noses worked as personal heaters, warming and humidifying the cold, dry air they inhaled. For that kind of extreme weather, these impressive nasal skyscrapers turned out to be quite handy. When our Homo sapiens ancestors decided to leave the sunny savannas of Africa for a spot of frostbite up in Eurasia, they bumped into the Neanderthals. This encounter resulted in not just an exchange of pleasantries, but also an exchange of genes that coded for larger noses. This newfound genetic nugget was discovered by scientists who dug deep into the DNA of over 6,000 volunteers. To complete the study, these scientists meticulously compared this genetic data to snapshots of the volunteers' faces. They measured the distances between various points on each face, such as the height of the volunteers' nose bridges. They then played a game of spot the genetic marker to identify if certain facial traits were linked with specific genes. By the end of this exciting chase, they hit the jackpot. 33 shiny new genome areas were linked to facial features. One standout gene, named ATF3, was traced back to our Neanderthal ancestors and seemed to be the maestro of controlling nose height. Participants with Native American ancestry had Neanderthal hand-me-downs in this gene, contributing to their taller noses. Think of the ATF3 gene as a Neanderthal housewarming gift to us humans as we stepped into colder climates from Africa. Interestingly, this isn't the first time our ancestors have played pass the gene. Back in 2021, the same research team uncovered a gene influencing lip shape called TBX15. This gene was a little love note from the Denisovans, another set of our ancient relatives, who lived in Asia and went extinct around 30,000 years ago. Another part of the scientific community believes our Neanderthal buddies had this weird genetic feature when it came to their brains. Is that why they didn't make it? Through this theory, it was suggested that US humans might owe our brainy edge to a quirky gene mutation. This mutation gave our neocortex, that's the smarty pants part of the brain, a little population boom in the neuron department. This amazing gene of ours isn't all that different from the Neanderthal version. It's just one amino acid off, just like ordering a coffee with one sugar instead of none. This tiny tweak is found in virtually all modern humans. Meanwhile, our extinct relatives, the Neanderthals, Denisovans, and other primate pals, all missed the mutation memo, at least according to the study. Now, let's not get ahead of ourselves. Just because we have more neurons doesn't necessarily mean we're geniuses by comparison. But these results do suggest that we might have rewired the brain in a way that gave us a cognitive leg up. Also, it's not all about this lone amino acid difference. It's just a piece of the puzzle. Scientists have previously found a whopping 96 differences between our DNA and that of Neanderthals that could have potentially affected our different outcomes as species. Studying Neanderthal DNA also gave us some insight into their relationships. In fact, we now have some solid evidence of what a Neanderthal family looked like, and surprisingly, it's not really that different from ours. For this study, researchers gathered information from a Neanderthal archaeological site located in Asia. They discovered that one particular family included a doting Neanderthal dad, his teen daughter, and a sprightly young lad who was possibly their nephew or cousin. Part of the group was also an older female relative, maybe an aunt or granny. Now, our young damsel would eventually pack her bags, wave a teary goodbye, and leave her papa's home when she found Mr. Right. Had she been a boy like her young cousin, she would have been a happy homebody. But worry not, she wasn't stepping into a world of strangers. Her new community likely had some familiar, friendly faces. But how were scientists able to predict the ending of this story? By browsing through their gene pool, researchers were able to figure out that the Neanderthal social structure was patrilical. What this means is that most female Neanderthals left their homes when choosing a partner and started a new life with another family. The same research shows that our cave-dwelling clans likely weren't living in isolation either. Families living close by were probably visiting the same rock sampling areas to make their stone tools, the equivalent of a neighborhood hardware store. And when they weren't tooling around, they were busy hunting delicious meals like ibex, horses, bison, and other wandering critters. Scientists, however, were careful to add that this ancient family portrait might not represent the full spectrum of Neanderthal social life. They've kindly asked future archaeologists to get more Neanderthal DNAs on the Ancestry websites.
54,000 years ago, there was one interesting group that lived in caves. A father, daughter, and a couple of other members who were their close relatives. And the cool thing here is that they were the first Neanderthal family we know about. a team of scientists studied ancient DNA from their teeth and bones to learn more about early human society. And this research showed a cool thing. They probably lived in these caves at the same time, together. There were 11 Neanderthals that lived together in one cave, and 2 others from another cave that was somewhere close in the neighborhood. So there were 13 of them, 8 grown-ups and 5 kids. Together with their DNA, scientists also found their stone tools and animal bones. Neanderthals are the ancient human relatives that are definitely the closest ones to us. Their skull was long and flattened if you compare it to the skull of Homo sapiens that's more globular. They also had this specific prominent brow ridge above the eyes. You can easily recognize them by their face too, with the central part of the face protruding forward. Plus, they had a large, broad nose. Some believe their nose was a way of adapting to living in cold, dry environments. When the inside of the nose is bigger, it moistens and warms the air you breathe better. Unlike us, they didn't have much of a chin. Also, scratch marks on their front teeth tell us Neanderthals used them like a third hand when they would prepare food and work with materials they used. Their bodies were strong and muscular, with wide shoulders and hips. Their average height was 5 to 5.7 feet, with a weight of 140 to 180 pounds. Their stocky appearance with short lower arm and lower leg bones minimized their skin surface, better protecting them from the cold. Their lifespan was about 30 years, even though some of them lived longer than that. Neanderthals would dwell in regions that are now Europe and Asia for over 350,000 years. They disappeared somewhere around 40,000 years ago. That's about the time we could find traces of Homo sapiens in Europe. Their families were close-knit groups of 10 to 20. That's a lot less than the population of any ancient or modern human community. It's more like the size of groups of endangered species that are close to going extinct. These Neanderthals lived in their caves with small communities, but they didn't live isolated from the rest of their kind. They relied on each other for survival. They took care of one another, especially those who couldn't care for themselves. Also, their caves aren't as primitive as we might imagine. For example, they had a hole close to hearths and they would probably use it to heat water. Also, they would organize their space. They had sleeping areas, parts of the cave where they could leave trash, and areas where they could make stone tools and prepare their food. They would travel through the river valleys to catch their prey, such as bison, ibex, horses, and other animals. They were skilled in planning their strategies. Some studies showed they were aware of reindeer migration patterns, so they would plan their actions according to their predictions of where their prey could move. One of the biggest animals they would go after was the woolly mammoth. You know them, a relative of modern elephants covered in fur with a weight of up to 12,000 pounds that went extinct a long time ago. And studies showed woolly mammoths and Neanderthals shared some genetic traits. It's not that surprising when you think about it. Both species developed from African ancestors before they managed to adapt to the cold, harsh climates of Eurasia during the Ice Age. So they faced similar conditions and both went extinct at about the same time. Neanderthals also used stone to make tools, similar to ones other early humans used, such as scrapers and blades made from stone flakes. These tools scientists found in both of the caves they studied are created using the same raw materials. That means the communities probably hung out and interacted with each other in some way. Until the 20th century, many thought that Neanderthals were very different from modern humans, considering their genetics, physical appearance, and behavior. But more recent discoveries about this well-preserved Eurasian fossil population have shown that some of the people in it were the same as people alive today. Neanderthals lived before and during the last ice age, in some of the harshest places that humans have ever lived. Besides their tools and catching animals, they also gathered plants from around their area. They would also eat cooked vegetables relatively often. Their ability to stay alive for tens of thousands of years during the last ice age is a good example of how humans can adapt to almost any situation. Neanderthals made the earliest cave art that we know about. Scientists explored 3 Spanish caves where they lived, and all of them had black and red paintings of dots, animals, and geometric symbols, together with handprints, hand stencils, and engravings. These paintings were made more than 60,000 years ago. Since Homo sapiens came to Europe 20,000 years after that, we can assume Neanderthals were the only human species on the continent at the time, so they must have been the ones who created this art. Also, these caves were 435 miles apart, so it wasn't like only some of the Neanderthals knew about it. Paintings were obviously their long-lived tradition. They were also big fans of fashion. They made their own jewelry, some of it out of eagle talons. The oldest examples we could find are nearly 130,000 years old. They also most likely used pigment to camouflage or decorate their bodies. Also, Homo sapiens weren't the only species that used fires. Researchers looked at more than 140 fireplace sites across Europe and realized Neanderthals used fire there for a long time too. These signs included charcoal, burned bones, and heated stone artifacts. Neanderthals used fire for cooking food and making tools. They would stick wooden shafts into pieces of stone with pitch, which would be like natural glue. Since burning the bark of birch trees is the only way to make this sticky liquid, the Neanderthals must have been able to control fire. Most people imagine Neanderthals probably grunted, but that's not true in reality. They didn't quite sound like us either. Their big chest, posture, and the shape of their throats probably resulted in a voice that was louder and higher pitched than the average human's voice. They probably didn't have sophisticated vocabularies as we do, but they could use complex speech because they had the hyoid bone. It's this little thing we have in our neck too, the one that supports the root of our tongue. It's the same feature that allows us to vocalize as we do. They were more similar to us than we might expect. Some believe Neanderthals even built boats so they could sail across the Mediterranean. And it's not like Neanderthals lived somewhere, went extinct, and then modern humans showed up. It seems these groups did meet around 100,000 years ago in the Arabian Peninsula or in the Middle East. That's when the first groups of modern humans were moving from Africa. Scientists analyzed the DNA of one of the Neanderthal women that lived more than 50,000 years ago, and it includes genetics from modern humans too. Some traits we have, like skin and hair color, mood, and sleeping patterns, are connected to the amount of sunlight we get. Neanderthals lived in Europe and Asia for a long time before modern humans arrived there, so they were used to less sunlight compared to the ones who came from Africa. Neanderthals had different traits because of their exposure to less sunlight, and these traits were passed on to their offspring when they had children with modern humans. In other words, some of the traits that modern humans have today are influenced by Neanderthal genes. For example, people who are night owls often have Neanderthal genes. Also, around 1% of Neanderthals had light skin, red hair, and perhaps even freckles. Over the years, archaeologists have uncovered all kinds of stuff on runestones, curses, poems, protective magic spells, and even inheritance disputes. However, a newly uncovered ancient Norse artifact known as Svingerud stone has just one word on it. Sounds boring, right? Well, think again, because this might just be the oldest runestone ever discovered, almost 2,000 years old. But that's not all. Excavations are still ongoing, and depending on what follows next, it could unravel secrets and the true meaning behind the mysterious magical runes. So let's explore and see just how much known history you can rewrite with only one engraved word on a stone. A long time ago, during the first few centuries of the Common Era, Scandinavians and Romans crossed paths. They traded goodies like glass and silver. And eventually, Roman customs and even written culture ended up north.
The Nords liked the Roman alphabet but wanted their own letters copyrighted, so they decided to create their own unique characters, which they called runes. Almost 20 centuries later, in 2021, archaeologists were excavating an Iron Age burial site near the village of Svingerud in eastern Norway. Among the cremation graves, they uncovered a reddish sandstone slab that would become a centerpiece in a major Norwegian archaeological discovery. It's the size of a coffee table, measuring just over 12 inches across. The stone was found buried with burned bones and charcoal, part of an early cremation grave. The stone had runes engraved into it, looking rough and shallow, like they were scratched with the tip of a knife or something needle-like. Runestones are not unusual. Archaeologists are used to uncovering runic inscriptions, especially in this region. However, tests show that both the burial site and the carving on the stone likely date back to somewhere between the 1st and 3rd centuries. That places it deep in pre-Viking history, centuries before the Viking Age officially began around 800 CE. That makes it one of the oldest reliably dated examples of early writing in Scandinavia. When you look at these carvings, they either look like magical symbols made to call on Nordic deities to help you, or like random scratches made by an angry man hitting a stone with something sharp. But these are real letters, crude but intentional. It's an ancient writing system used by Germanic tribes across Northern Europe. They were engraved into wood, bone, or stone. Their shapes are straight, angular lines because curves were tough to carve with the tools they had back then. When they met with the Roman Empire, rather than just borrowing Latin letters, the Germanic tribes took the idea of writing and carved out their own version. The original alphabet was called Elder Futhark. It had 24 letters. We can find them on artifacts dating from around the 2nd to the 8th century CE. Its name comes from its first 6 letters: F, U, Th, A, R, and K. Each rune probably had a name that matched the sound it made. For example, the rune that sounds like A was called Anzus. However, nobody from back then left us a memo explaining the names. In fact, the knowledge of how to read them was forgotten until 1865, when Norwegian linguist Sophus Bugge deciphered them by comparing clues. He examined later rune alphabets and ancient poems that referenced the runes, like a detective sketching a suspect from scattered witness clues. For many runes, especially the oldest ones in the Elder Futhark, the meaning is still open to interpretation. They weren't common knowledge, which is reflected by the fact that only some 350 surviving inscriptions remain. This changed eventually when the Scandinavian language evolved from Proto-Norse into Old Norse, spoken by mighty Vikings. The Elder Futhark was reduced from 24 to 16 runes to reflect the changes in the language, thus becoming the Younger Futhark, which was far better spread. Runes weren't really used to write books or keep daily records. Instead, you'd find them carved on gravestones, weapons, and various tools. It's believed that people used runes to show ownership, honor loved ones who had passed away, leave short messages, or sometimes for protection or magic. In the early days, some runes probably had special spiritual or ritual meanings too. One interesting fact about runestones specifically is that they were often used for self-promotion or boasting, like an ancient social media status or a tweet posted on a wall, or better said, a stone. One such example of a runestone from the 11th century where a man named Vigmund had it carved for himself, calling himself the cleverest of men. He even added that he was a ship captain, and yes, he made sure everyone knew that while he was alive. In the Old Norse poem Havamal, Odin says he hung on the world tree for 9 nights, pierced by a spear, to gain knowledge of the runes. This goes to show just how powerful and mystical those symbols were perceived to be. It's fitting that the word rune comes from a Proto-Germanic word which can be translated as secret or whisper. There's a common saying about power being in words, and for the old Germanic tribes, that power felt like actual magic. It's also why it's important to know when this magic came to be. And the Svingerud runestone tells us that. But it's not just when it was written. it's also what's written on it, where and why. The location where the Svingerud stone was discovered is already a significant archaeological site. It's famous for its incredible discoveries, including the remarkable Jormungbu helmet, the only Viking helmet ever found in Norway. The stone was placed in a cremation pit, alongside the remains of an adult and a few personal items. Thanks to charcoal and bone samples, researchers can figure out how old the runestone is by using a method called radiocarbon dating. The Svingerud stone isn't the first ancient Norse artifact with runes that archaeologists have discovered, not even close. People carved runes into all sorts of everyday objects like combs, jewelry, and knives long ago. Some of those might even be just as old. Other finds have runes, but they're often broken, loose, or don't have clear dating. However, with radiocarbon dating, scientists have confirmed that the Svingerud stone is really the oldest runestone ever found. The writing on it suggests that it was part of a ritual and might have even been a message to the deceased. The inscription isn't long. It's just one word, Idiburg. No one knows exactly what it means. The clearest part says Idibera, and most researchers agree it's probably a name. Maybe Idibera in a genitive form, meaning of Idibera or belonging to Idibera. So this could be the name of the person buried there or someone being honored. There's a decent chance it's a female name, possibly making this the earliest known female rune inscriber in history. But researchers now believe that the Svingerud runestone is a part of a bigger monument. They found more than a dozen sandstone pieces scattered across several graves at the site, and when they assembled them in the lab, they fit together like a puzzle. This suggests they all came from one single upright stone. The main piece with the inscription was found in one grave, but other similar pieces were buried in nearby cremation pits. Archaeologists think it was broken and reused in a ritual, maybe to connect different people or generations who had been buried there. Instead of just marking one grave, it might have first been a memorial and was later put back into the other graves as a symbolic act. Some even speculate that the runes might have been carved by different hands throughout various time periods. The Svingerud stone might be small, but as the oldest runestone ever found with a secure archaeological context, it could be the key to how writing first took root in Northern Europe. This Norwegian archaeological discovery proves that runes were already tied to ritual, memory, and maybe even women. And if it's just a fragment of a larger monument, we've only seen part of the picture. Ancient Norse artifacts like this reshape what we know about pre-Viking history. And with luck, more runestones will follow, maybe even from another female rune inscriber.
Now this bad boy was the size of a husky and could maybe pass for one, except it didn't have any fur and was a top predator with extra long blade-like canine teeth. Ooh, charming. Meet the earliest known saber-toothed animal to have ever lived. It roamed the earth well before the dinosaurs. Scientists made the description of this creature based on its fossils found on the Spanish island of Majorca in the Mediterranean Sea. About 200 million years ago, none of us were around then, the very first true mammals appeared, and they lived right alongside the dinosaurs. But if we trace the family tree of mammals even further back, we'll find an ancient group called Therapsids. They didn't look like mammals we have today, but they had some key features that would eventually help define mammals. For example, Therapsids had special openings on the sides of their skulls for jaw muscles, and parts of their jawbones would later evolve into the tiny middle ear bones that all mammals, including you, have today. So, the new discovery is what might be the oldest known Therapsid fossil. The fossil, which doesn't have an official species name yet, belongs to a group called Gorgonopsians. Those guys are more closely related to mammals than they are to any other living animals. Some of them were as small as cats, and others were as massive as polar bears. Gorgonopsians had some very mammal-like traits, like different types of teeth for different jobs. But unlike mammals, these ancient predators kept replacing their teeth, even their giant saber-like canines, over and over during their lives. Hey, that would be handy. Until now, the oldest Gorgonopsian fossils we knew about were around 265 million years old. But this new fossil is even older, dating back between 270 and 280 million years. The find was super detailed and complete, including its sharp knife-like fangs, part of its jaw, pieces of its spine, ribs, tailbones, and toe bones, plus most of one of its back legs. Even though the creature's skull wasn't complete, the scientists think it was about 7 inches long, and the animal itself would have been around the size of a medium-large dog, weighing between 66 and 88 pounds. But other than that, it didn't really look much like a dog. Even though it had some lizard-like features, calling it a lizard dog is totally wrong. Mammals and reptiles do share a super ancient ancestor from about 320 million years ago, but their evolutionary paths split a long time ago. When the newly found creature was alive, the island of Majorca was right in the middle of the gigantic supercontinent Pangaea. Back then, this area went through super wet and super dry seasons. Scientists have always wondered if major moments in mammal history happened in tropical places like this, but we just didn't have the right fossils to prove it. Now, with the discovery of the oldest known Gorgonopsian in Majorca, the missing pieces of the puzzle are coming together. It looks like some huge steps in mammal evolution could have happened in low-latitude environments we haven't explored much yet. The so-called gap in the fossil record might just be because paleontologists weren't looking in the right spots. Our hero of the day wasn't the only cool guy rocking the planet before dinos settled in. Over 500 million years ago, the weirdest predators to have ever existed ruled the oceans. The name is a bit tricky to pronounce, so I'm not going to. Okay, it's Anomalocaris, but it just literally means unusual shrimp. This creature looked nothing like anything alive today. Scientists think it was the first true apex predator, the orca of its time. Anomalocaris was massive for its era, as it grew up to 3 feet from its sharp grabbing arms to the tips of its tail fins. For a while, everyone thought trilobites were its go-to meal, but new research shows it wasn't strong enough to crack open trilobite armor. So instead, it was a speedy, agile hunter with awesome vision, and it often picked off soft-body animals that zipped through the open water. Now, another really cool creature from pre-dino times is a fish that could walk on land. Tiktaalik lived in marshy rivers that looked a lot like today's Amazon rainforest. It could grow up to 9 feet long, and it found its prey in rivers and inlets like a modern-day freshwater crocodile. It had a flexible neck and even some early versions of lungs, and thanks to them, it could survive both in water and out of it. Why fish like Tiktaalik started moving toward land about 395 million years ago is still a bit of a mystery. Around that time, the ancient supercontinent called Gondwana was drifting closer to the land that would become North America. This slow movement created lots of shallow, swampy habitats, which were perfect places for crocodile-like animals to thrive. Plus, these areas were near the equator, so they were warm and tropical. But there wasn't a lot of food waiting for them on land, so maybe they moved there for safety reasons. There were fewer predators and better spots to lay eggs there compared to the water. Creatures first adapted to living in open water, then shallow water, then marshes and river edges, and only after a long, slow transition did they finally step fully onto land. Now, how about a millipede the size of a small car and weighing as much as a large dog? This beauty lived over 300 million years ago in what is now England. Back then, during the Carboniferous period, Earth's atmosphere had way more oxygen, over 26%, compared to today's 21%. Scientists used to think the high oxygen levels were the only reason these creatures could get so big. But back then, they found a new fossil from a time when oxygen wasn't that much higher than today. They discovered it purely by accident, when a boulder split just right and revealed one of the most complete and largest giant millipede specimens ever. This one could have lived not just in swampy areas, but also in open woodlands filled with tasty seeds, nuts, and maybe even small animals. There's a chance that this beast wasn't a slow, plant-munching crawler, but a predator that would snap up whatever it could find. After dominating the Earth for about 45 million years, the giant millipedes eventually vanished. Probably the reptiles pushed them out, clearing the way for the age of the dinosaurs. Now, in case you ever wondered what would happen if you crossed a polar bear with a saber-toothed cat, here's the answer. This guy ruled the southern ecosystems after migrating 7,000 miles across the supercontinent Pangaea around 252 million years ago. It had a tough skin like a rhino's and massive canines, perfect for tearing away huge chunks of meat, and it was an excellent runner. Once it got to its new home in what is now South Africa, it replaced a whole group of local predators. But its glory didn't last long, as closer to the end of the Permian period, massive volcanic eruptions made the weather patterns change and wiped out about 90% of all species. And because top predators are usually big, slow to grow, and not super common, they often vanish among the first when massive extinction events hit. And that's how our guy here went extinct. Our final creature of the day was a dragonfly that lived around 300 million years ago and had a wingspan of over 2 feet, 6 long, spiny legs, and huge, bulging eyes. Meganjura. This 4-winged giant is most likely the largest flying insect that ever lived, and it easily outsizes today's dragonflies, which are its distant relatives. Like modern dragonflies, Meganjura like to hang out in open areas near ponds and slow-moving streams. But unlike today's dragonflies, it wasn't just catching tiny bugs. This guy was likely the top predator in these open spaces. It used the spines on its legs like a flying trap to snatch prey out of the air, including other flying insects, small amphibians, and even lizard-like creatures. Scientists found the first fossils of Meganjura in 1880 in the coal-rich rocks in France. The fossils were incredibly well preserved and showed off the detailed vein patterns in their wings. Scientists think Meganjura grew so huge because it didn't have much competition from vertebrates, and the air back then, during the Carboniferous period, had a lot more oxygen than it does today.